In this presentation, we will show how to create a mask for Xraster. The mask plays an essential role in analysis and is used for exporting analysis results as raster layers to QGIS. Creating a mask involves 5 steps. The first step is to prepare a polygon layer with an attribute corresponding to the identifier of a given zone. It is important to ensure that the coordinate system of the vector layer matches the data. A vector layer of polygons dividing the Baltic Sea has been prepared. It uses a geographic coordinate system. The attribute table contains an integer field with the identifier of a given zone. Opening .NET-CDF files in QGIS is generally possible, but it becomes extremely cumbersome when the data contains a large number of layers. Therefore, from our data, we will create a .NET-CDF file containing only one layer that represents the number of rows and columns, as well as the georeferencing of our data. In Xraster, we open our data. Please note that we have a total of 29 times 372 layers, amounting to 10,788 layers in total. Opening them in QGIS would be very cumbersome. The layers consist of 149 rows, height, and 178 columns width. We navigate to the Subset tab and create a subset corresponding to a single layer. It is very important to adjust the coordinate range to be larger so that it fully encompasses the layer. This can even be done with some margin. We obtained a slice of space at a single time and depth. Now we go to the Clip Join tab and export the subset to a .NET-CDF file. We can open the created file in Xraster. We will receive a message stating that the file does not have a time dimension. If we click OK, its information will be displayed. We can see that, indeed, it does not have a time dimension, although time is included in the coordinates. The number of rows and columns is identical to our data, 149 rows and 178 columns. The third step is to open the created file in QGIS and assign it a coordinate reference system, CRS. We can see that the layer has appeared on our vector mask. The vector mask can be of any size, but it should be in the same coordinate reference system. Only its portion that overlaps with our data will be used. In the next step, we will use the Rasterize Vector to Raster tool to rasterize the vector mask and simultaneously clip it to the size of our data. We input the vector layer and the field with the zone identifier. We set the raster size unit to pixels and the width to 178 and height to 149. We input the extent corresponding to the created layer from the data and click Run, creating a temporary raster. A raster layer named Rasterized has been created. We check that it contains the correct number of rows and columns and has the proper coordinate reference system. The final step will be to convert the no data values in our mask to 0. To do this, we will use the Fill No Data tool. We open the Fill No Data tool. We input the name of the created raster and set the fill value to 0. Then we save it as a GeoTIFF raster. Our mask is ready. We can now apply a symbology to it. We can also open it in Xraster after importing our data.